Thank you very much. As outlined, what I'm going to talk through briefly is a collaboration that Minnovare had with Evolution Mining a couple of years ago that resulted in the development of a new piece of technology. But importantly, I'll also touch on the value that that collaboration has delivered, not just for Minnovare, but importantly for Evolution, our development partner. Briefly about Minnovare, we specialise in advanced drilling technology. We're headquartered in Perth. We also have operations in the US and Canada. We developed and launched the azimuth aligner. It's now the most widely used drill rig alignment system within exploration. And on the back of that, in early 2018, we launched the production optimizer, the technology that I'm talking about today. Our technology is used in over 120 mines globally. And as a business, we place a strong emphasis on collaboration. One of those is what I'm talking about today. Evolution are a company that really don't need any background. Cracow itself is an underground gold operation in Queensland. It's got a narrow vein, steeply dipping ore body and use a long hole stoping extraction method. They output around 90,000 ounces of gold per year. Why they were such a great partner for us was quite a bit of work had already been done by the engineering team to determine the issues they were facing and also identify some of the causes. And what they found was that blast hole deviation in their long hole drilling was causing excessive dilution and rework due to bridging. This was actually being exacerbated as they mined deeper in the deposit due to the narrowing of the ore body. And they also noted that some of the complexity with the process and the technology used to align the rigs was a contributor to their issue. So why was this collaboration important? Well, for Minnovare, it gave us access to a real-world test facility, a working underground mine, but also it enabled us to identify and engage the key stakeholders. This meant that we could identify who they were, what their needs were, and ultimately we knew that would streamline the adoption of our technology once the commercialization had been complete. It also enabled us to build a more valuable solution based on the needs of the customer. And again, we saw that this was a benefit not just for us, but for our clients and for the industry as a whole. Cracow was also an ideal test case because they had done an extensive drill hole deviation study in 2016. And what we found when we sat down with the engineering team to look at that data, it actually aligned really well with analysis that we'd conducted from 5 other underground operations in Australia. And that was data based on in-hole survey data that our clients had given us to conduct some analysis. What this slide shows is this is really a summary of that analysis that we conducted. So on the left-hand side, you can see is the percentage contribution that alignment error, collar position error, and in-hole deviation was having to the overall deviation at the end of a blast hole. So what this data was, it was a combination of in-hole survey data and collar pickups from mine surveyors. And what we can see is that actually the alignment of the drill prior to drilling of the hole was actually the largest contributor to the deviation at the end of the hole. Second to that was in-hole deviation, and finally collar error or collar location error. But importantly for us, and the key takeaway in the problem that we wanted to solve was that over 75% of the deviation at the end of an underground blast hole could actually be attributed to factors that occurred before the drilling actually commenced. Another challenge that the engineers at Cracow had identified was some of the complexity associated with the alignment of their long hole rigs. They had noted that there was multiple sensors on the rigs, all needed to be maintained and calibrated to get an accurate outcome. A key part of the process was the surveyor marking a laser reference line and an operator orientating the rig to that reference. And really the outcome here was very much dependent on the skill and the diligence of the operator. We saw that the systems could break down from time to time, but importantly, there was often a lot of data, but it wasn't being collected, it wasn't being analysed, and it certainly wasn't finding its way back to the engineers in a timely fashion. So what we found was that the alignment accuracy was really dependent on the surveyor, the rig, and also the drill rig operator themselves. So the technology that we developed was really developed to overcome some of these challenges, and it became the production optimizer. Importantly, when we started, we had a focus to ensure that this system could be retrofit to any make of model, regardless of age. And what we've seen from our clients who have implemented this technology over the last 12 months is a reduction in their average blast hole deviation of up to 70%. I'll touch briefly on some of the key components before moving on to the results at Cracow. But our digital platform, Minnovare Core, is our online data hub. Importantly, that integrates with the drill and blast software already used by our engineering clients. But importantly, it digitizes what is still very much a paper-based process on a lot of underground mine sites. The second part is those digital drill plans are then passed to the engineer, and other critical information that occurs during the drilling process captured, and then that information passed back to the engineer at the end of shift. Our OptiBox is a highly accurate sensor that we retrofit to the rig. It works independent of the rig's current systems, and it ensures that rig leveling and alignment to a laser line are now a non-critical part of the process. And finally, the Smart Collar feature gives the driller an automated means of calculating a new trajectory for their hole to ensure they end up in the same place in the event that they have to offset their collar starting location. So onto the analysis. Once we had finished the testing of the system, Cracow moved ahead with implementing it on their 2 underground long hole rigs in January 2018. And at the end of the financial year, we sat down with the engineering team to conduct an analysis to actually quantify the benefits the system had delivered. The engineers selected 28 stopes, which represented about 20% of the total production for the financial year. And what they were able to see was that the production optimizer had reduced their average deviation by 30% across those stopes. What they also found was that the 17 stopes that had been drilled using the production optimizer recorded a 63% reduction in dilution when compared to the stopes that they had analysed that had been drilled using the conventional means. This is this data displayed in a different way, and there's really 2 key takeaways from me here. First of all is the reduction in average dilution. You can see goes from just under 30% using their traditional methods down to an average dilution of just under 12. But importantly, if you look at the 2 sets of data, you can see that not only did the production optimizer deliver a better outcome, but also a more consistent outcome. And that can be seen clearly when we look at the standard deviation. It's just under 19% using the traditional methods, reduced to just under 6 using our technology. Importantly, what does all that mean? So the next step, the engineering team sat down and said, well, if we had achieved these results over a full financial year, what should we have expected from a productivity perspective? And first of all, the reduction in dilution experienced during the 6-month period would achieve overall a 45% reduction over their full year. What that would mean for the operation, in the event that they can maintain the same tonnage output from the mine, would be an additional 8.2 million in revenue from additional ore recovery and 4.5 million reduction in costs associated with dilution. That would translate into a 22% return per tonne increase. And based on that, the mine had the confidence to reduce their target dilution from 20%, which was the target in FY17, down to 10%, which is the target for the current financial year. So in closing, in addition to some of the direct benefits that the mine site achieved, there's actually some more bigger picture implications for our clients. The system delivers a more consistent, more accurate drill hole, and that's enabled engineers, it's given them more confidence to try new stope designs. Our clients are now trying new ambitious blast patterns in an effort to economically blast and extract previously uneconomical stopes. What this means in the future is a potential to look at reducing mine production and development costs through increasing level spacing. And also we see that this technology and the data we capture is key to facilitate a pathway towards the automation of this process. But ultimately, it comes down to the bottom line for most of our clients. And what we've proven we can deliver is an improvement in the net present value of their assets. So that's me pretty much out of time. We do have a booth here. Please come and see us at Stand 8. We also have a detailed white paper that was co-authored with Evolution Mining that provides a lot more detail. And myself and my colleagues would be happy to answer any questions that you may have. Thank you very much.